let's talk about treatments for ADHD and why stimulant treatments in particular can be so effective. First of all, it's long been known that there are specific brain networks involved in what we call attention. Now, attention is not one thing, actually. It involves several different cognitive operations, including the suppression of noise, that is, turning down the background chatter in our heads and turning down our attending to things outside us like noises or visual cues that are not relevant to what we want to do. And it also involves ramping up or attending or focusing on particular things that are happening either in our immediate environment or in our head or both. So if that all sounds rather complex, indeed it is. It involves several different networks operating in parallel. But what we know for sure, based on a lot of clinical and scientific laboratory data, is that the so-called prefrontal cortex, the region of neural real estate in your brain just behind your forehead, is critically important for orchestrating which neural circuits are going to be more or less active at a given moment in order to bring about what we call focus or attention or task switching or our ability indeed to multitask, because we can actually multitask to some extent. In fact, if you were to look at somebody and focus on perhaps the expression on their face, you could do that while also attending to a conversation that's happening nearby. It's energetically demanding. It's hard to do, but we can do that. That's actually referred to as covert attention. You're covertly paying attention to something else. And then you can switch that attention back to just one thing or one small collection of things. The point being that attention is a powerful resource. It's what allows us to navigate through life with efficiency and to be adaptive in our behaviors. It's what allows us to learn and to build relationships and to have successful school careers and professional careers and so on. But it is indeed expensive. It takes metabolic resources. Just at rest, if you were to think about essentially nothing or whatever just pops into your mind with no dedicated effort toward paying attention to anything, your brain would consume about 25% of your daily caloric needs. And then when you lump on top of that your need or your attempts to focus on things, to pay attention to specific things, it should come as no surprise as to why that often can make us feel tired, as if we've been working really hard or we've been running a quote-unquote mental marathon when trying to learn and attend to things. It's hard work for the brain, and yet we can pay attention because of that very precious real estate just behind our foreheads, the prefrontal cortex. And what we know for sure, based on many brain imaging studies, is that ADHD is not necessarily a deficit in prefrontal cortical function, but rather the prefrontal cortex's ability to communicate with other brain areas in the proper ways. And so what results in the brain of a person, either young or old, with ADHD is that a lot of the background chatter becomes very, very loud. So for instance, we have a brain network called the default mode network. This is a fascinating brain network. This is the brain network that is active when you just sort of sit in place and don't think about much, and then you start having ideas about what you might do next week. It tends to be very autobiographical, so you might remember an experience from the past. You might think about some of your desires, some of your dislikes. This default mode network, as it's called, is also involved in our imagination, in our spooling together of different experiences that we've had. It doesn't tend to be the thing that's really focused on anything external in particular all at once. The default mode network is always active, but it's when we start to attend to something, especially things external to us, like something written on a page or a conversation or something that we really need to learn, something we need to pay attention to, that the activity of the default mode network is suppressed somewhat. And that suppression occurs not just by accident, but because the prefrontal cortex is actively suppressing it. In kids and adults with ADHD, the default mode network is often still active at a very robust level, even while we're trying to attend to things. And that's why someone with ADHD will sit down and try and do some focused work, and they'll start thinking about something they want or something they dislike. Their internal state will start to distract them. And of course, there are other networks in the brain. There's actually what's called a true salience network. There's the dorsal attention network. There are a bunch of different networks in brain areas. But again, when thinking about ADHD, and especially when thinking about how the drugs that we're going to talk about today work to alleviate the symptoms of ADHD, and in thinking about why so many people use or even abuse these drugs for sake of learning or recreationally, we might say, you start to realize that everything centers back to the prefrontal cortex and the prefrontal cortex's ability to actively suppress and actively enhance the activity of these multiple brain networks, including default mode network, salience network, dorsal attention network, etc. So rather than overwhelm you with a bunch of names of brain areas and brain networks, today I'd really like our discussion to focus on first what the various drugs that are used to treat ADHD are. That is, how do they work at the level of neurons? Second, how they create a certain set of conditions that allow the prefrontal cortex to be a better conductor. Third, how that can be leveraged during development to actually teach the prefrontal cortex of a young child to learn to be a better conductor, because that's really the hallmark of the use of these drugs, is to try and enhance the activity of particular circuits to create a sort of learning so that the prefrontal cortex is much more efficient at doing its job of conducting. And then fourth, we're going to talk about the various things that I think most people out there ask about when they hear about drugs like Adderall, Vyvanse, and Ritalin, et cetera, which is, are they addictive? Why are they addictive? Can one use them briefly or even from time to time and still be okay? What if I use them as a child and I don't want to be on them anymore? Should I put my child on these drugs, et cetera? It is, I believe, only by understanding the biology of how these drugs work and their potential both to improve brain function, but also some of the dangers associated with these drugs, that one can really answer those questions for themselves or for their children.